Talk about Niels Bohr, and he was a physicist who studied spectroscopy, which is the study of light splitting into its different wavelengths. And then he studied the bright line spectra, which is a series of light bars seen for a particular element. And the bright line spectra are considered fingerprints of elements because they are unique to that element. And you need to remember that each color represents a different wavelength or energy. And then he reasoned that when electricity goes through the hydrogen gas, it causes the electron to gain energy and move to a higher energy level. So you can see this is like the nucleus, and that little dot is the electron, and it moved from a lower level to a higher level. And then the excited electron goes back to a lower energy level. So we'll see that after it's already went out to a higher energy level, then it's going to go back inside. So it's going to go from the outside to the inside, and then light will be emitted. So all that energy does not disappear. It's given off as a bar of light known as the spectral lines.
And now for waves. This is a picture of a wave. And then the symbol for wavelength is you have a squiggly line and then just a straight line down. And when you draw the wave, you draw a straight line and you draw the first loop and then the bottom loop and then first loop and another bottom loop. And when you go up, this right here is the crest. So this would be a crest too. And when you go down, this area right here is called a trough. And with your crest area, when you go up, that is positive altitude. But when you go down, it is negative amplitude. And Louis de Broglie was the one who discovered this. And he said that only certain waves will not destroy themselves. Therefore, only certain energy levels are allowed.
Okay, and then we have Erwin Schrödinger, and he created a mathematic formula that treats electrons as waves. And it's a really long formula, but you don't need to worry about it because you won't have to know that. Okay, so this is going to be our first sample problem. If you look at your periodic table, it will really help you with this. So we know that for oxygen and for any other element, your protons and electrons are the same number. And if you look at your periodic table, you can tell that for oxygen, your number of protons is 8. And then therefore your number of electrons is 8. And your mass number is the number of protons plus the number of neutrons, which is going to be 18.
So beside oxygen, you have your hyphen and you write 18 for the mass number.
And then for this next one, you see that your number of neutrons is 42. And then your number of protons is 33, which tells you what element it is. So if you look on your periodic table, you can tell that the one with 33 is arsenic. And then you know that protons and electrons are the same. So then again, you get the same number for those. And for protons plus the neutrons, that's your mass number. So that's where you get 75.
And then right beside the hyphen and your name of the element, you write 75 because that's your mass number.
Okay, and then for the next one, the number of protons is 15, which tells you what element it is, so it's phosphorus. And then you know that your electrons and protons are the same, so that's where you get 15. And then since it already gave you your mass number, and you know that protons plus neutrons equals your mass number, then you can just say 31 minus 15, which will give you your number of neutrons, which is 16. Okay, so now we're going to talk about AP chemistry and a little bit of like in-depth chemistry stuff that if you decide to take AP Chem, then you'll learn about that.
Yep.
First, you'll probably learn about this equation, and it's C equals V times, what is that?
Wavelength.
Times the wavelength symbol. Forgot what it's called, but C is your speed of light, and that's 3.00 e
to the eighth.
Yeah, e to the eighth meters per second. And your V is frequency, and then that's your wavelength in meters.
Then you'll learn about how a shorter wavelength equals a higher frequency, higher energy, and higher energy equals greater distance from the nucleus.
And you'll also probably learn about gamma rays, which are higher energy photons produced in association with other forms of decay, and they're massless, and they do not by themselves change the nucleus.
And there's also another equation. It's E, capital E, equals HV. E equals energy in joules, and H is Planck's constant, which is 6.626 times 10 to the negative 34 joules per second. And V equals frequency.
And that basically just explains how energy of electromagnetic radiation is directly proportional to the frequency of radiation. So that's where we get into treating electrons like waves, and how, like Amber had said before, as an electron moves toward the nucleus, the wavelength shortens, and the shorter wavelength equals a higher energy. So therefore, a higher energy equals a greater distance from the nucleus, and that's how like you figure out between wavelengths of light and stuff, and how it turns into energy and all that kind of stuff.
And you can also see V, which is frequency. You can write it as F. Some people write it as F. It all depends on what you feel more comfortable with.
So these are going to be our sample problems for the end of the section. And our first one is an atom, and this is a nucleus. And the question is, the region labeled X, which is right there in the diagram, has a charge that is positive, neutral, or negative.
And the answer is negative, because the nucleus contains the protons and the neutrons, and proton has a positive charge and the neutron has a neutral charge, and the electrons are always outside of the nucleus, just floating around in the atom, and they always have a negative charge because they're electrons.
So these are our sample problems 2 through 4.
For number 2, it says the nucleus of most atoms is made up of blank and blank.
So, as we learned in the video, the nucleus is made up of protons and neutrons.
For number 3, the mass number of the atom is determined by adding the blank and blank.
Okay, so the mass number is determined by adding the protons and neutrons. Okay.
Alright, for number 4, most of the mass in an atom is in the...
And the answer is nucleus. So if you remember, the mass like most of the mass is in the nucleus because it's dense, and then the volume is mostly empty space. So for our last practice problems, we just have 5 through 8. And for number 5, the charge and mass number of a neutron are, and the charge number is
0.
and the mass number is
1.
and that was on that chart that was in our video also.
Yes.
And then for number 6, the charge and mass number of a proton are, the charge number is
+1.
and the mass number is
1.
And for number 7, the blank constitutes most of the atom's volume.
The electron cloud.
And last but not least, isotopes are atoms of the same element that differ in
The mass number.
and
The number of neutrons in the nucleus.
yep.
And neutrons are only located in the nucleus, if you forgot.
So that is pretty much all of our video. And we will make a little quiz for y'all. And if you just watch the video and take a few notes, it'll be pretty easy.
And
so no
for,
worries.
Yeah, for the AP section, that should only be extra credit. So
So you
but
might
still
have,
watch it because
Yes.
it's good information.
yeah, and you might have a couple extra credit there.
Yeah, just in case you get one wrong.
All right, bye.